Hello everyone. In this week's lecture, I'm going to introduce you to AIMSUN as one of the existing commercial powerful softwares for different kinds of transportation modeling. AIMSUN allows you to create different types of models, from microscopic models of an intersection or a roundabout or a single arterial or freeway to mesoscopic simulation of an entire region. In this week's lecture, we will focus on a travel demand modeling exercise. We will start with preparing and executing a generation and attraction experiment. We will then do the same for a trip distribution model and a mode choice exercise. We'll do traffic assignment next, and at the end, we'll learn how to manage all these experiments together by defining a four-step model experiment. What you need to do first is to follow the instructions given on Moodle on week 11 on AIMSUN as part of the pre-class activity. What I've done here is I have provided you with some detailed instructions on how to install and access AIMSUN license remotely, whether you're on campus or off campus, working from home, or with your personal computer or laptop. So I have provided you with two links for downloading the AIMSUN on either Mac or Windows machines. If you're working with AIMSUN off campus, you need to establish a VPN connection to Monash first. Make sure you follow the instructions given in the provided links to establish your VPN connection. Now that you've successfully connected to VPN, you need to go to this, you need to open your browser and go to this local host as provided here, and specify the license for this specific unit. It's a student license, it's a limited version, but it works for our purpose. After you specify the license, give it a few minutes to set it up, and you should be able to run and open AIMSUN accordingly. If you have any problem with running it, either contact me or contact Monash eSolutions, and we will try our best to help you running AIMSUN on your computer. Next, I would like you to download this AIMSUN zip folder that I've provided on Moodle. If you download the file, it will include two folders. One folder is including a exercise on four-step modeling. The other folder includes a traffic assignment exercise. In this week's lecture, we focus on the four-step modeling exercise, but I highly recommend you to also go over the traffic assignment exercise if you are interested. There's a tutorial inside each folder, so you should be fine following the instructions given there. So let's start with the four-step modeling exercise. I'm going to open this four-step modeling initial.ang. This is the initial version of the model that we're going to work with. So I go to my AIMSUN. I think I can drag this here and open it in AIMSUN. You can see here it says AIMSUN 8.1 Classroom Edition. So this is the model that we're going to work with. It's relatively a small model. You can see the centroids, every link, and we should be able to work with this to actually create a real travel demand model. So the network that we're working with already includes almost all the data we need to create a generation and attraction model. But let's have a look through the available data, and we'll complete it later before creating the trip generation and attraction scenario and experiment. To start, let's browse the project window. Here on the right side, this is the project window. You see there are multiple subfolders included under the project folder. Let's explore and locate transportation modes, time periods, and trip purposes. So if I go under demand data, I should be able to see a few other subfolders. I see time periods. You can see that AM peak period is defined. Let's double click on it. You can see that you can specify the start time and the duration to specify a time period. You can name it whatever you like. Here we've named it AM peak hour. If you want to create, for example, a new time period, you right-click on the folder time period, you click on new time period, and a new time period is created here. If you right click on it again and go to properties, you should be able to rename it. For example, let's rename it to PM peak hour, and the start time, let's do 3 p.m. and duration 3 hours. And if you click OK, you have successfully created a time period for your modeling purposes. We also have a folder for transportation modes. Here we already have all modes: bicycle, car, and public transportation. Again, if you want to create a new mode, you just need to right click on it and create new transportation mode as you wish. We also have a folder for trip purposes. We already have shopping, study, and work trips specified under this folder. So next, let's go and locate the generation and attraction dataset attributes, which is located under the folder macroscopic areas. So you can see we have defined a few areas in the model. We have a CBD area, we have a distribution area for non-urban zones, distribution area for urban. This is the generation attraction non-urban zones and generation attraction urban zones. So if I click on generation and attraction non-urban, you should be able to see the specification for that, which is required for a generation and attraction trip model purpose. So you can see we have the data set. I'm going to talk about this later, but the time period is defined as AM peak. You can have PM peak, but let's stick to the AM peak because the PM peak doesn't really have much information in it. We just created it. Transportation mode, you can select different types of modes. Here, let's select all, and the trip purpose: work, study, and shopping. And if you explore the factors included in this model, is for generation and attraction, we already have number of houses, number of residents, number of jobs, student seats, number of students, number of workers, and the shopping floor space as some of the factors in the generation and attraction model. So for example, if I choose work, you should be able to see that the only factor that is included in this generation model is number of workers with the coefficient 0.9. So if the number of workers increases, the number of trips generated in the generation and attraction non-urban will increases. And if you look at the attraction column, if the number of jobs increases, the number of attracted trips will increases. Now if I change this to shopping, you would be able to see that number of houses generates shopping trips, and the only factors that is included in the model is the for the attracted trips is the shopping retail floor that has a factor other than 0. Now let's open one of the centroids. I'm going to open this centroid here. I click on it, I open it, it's centroid number 37. It includes some information in it already. Under the main tab, you see a lot of information. Again, there are lots of information here already created, but if you go under tab land use, you should be able to see some information related to that this centroid is an external centroid, and we have, for different trip purposes, for the AM peak period, we have the number of departures and number of arrivals. This is the number of generated trips and the number of attracted trips, basically. Different attributes: external data, car availability. Everyone has car availability, but this external data is what I wanted to show you here. So now let's go back to the folder that we were working with, the folder from the forested modeling exercise. There should be a file there called census data 2012 text. So if I open this text file, you see some data from census, where each row represents a zone which is associated to each of the centroids in the model we saw. Each column represents a factor. For example, we have number of household, number of residents, jobs, number of seats, number of students, number of workers, and shopping floor space, as we saw. So for every zone here, we have a number associated to any of these variables. If you can't really understand this table, you can easily take it and copy it in Excel and make it a little bit more organized to see. But in a text file format, you see it a little bit like this, which is okay. So this is the file that we're gonna input or import into the model. So every single of our centroids will have some attributes. Going back to the model, if I go back to the centroid I was looking at, if you go under tab land use and attributes, you can see that the attributes are empty yet. We're going to use that census text file to actually fill this values of attributes for every centroid. So to do that, we need to go under the land use data folder, land use data sets, and we already have created this census data 2012, but it is empty. So if I double click on it, and if I go to import, I need to give this feature a little bit more information so it can import the text from that text file. So to start with, let's give it the address of the file that we were working with. So this is the address of my text file. The ID settings should be external ID. Reading settings, it's for lines to skip. Let's put 1 because we don't want it to read the first row of the text file. It's just the name of the columns. The text file has a column separator as a tab, and we're going to add the name of the variables that we're going to work with. So let's change this to centroid ID. The second column is number of houses. The third column is number of residents or number of inhabitants. The fourth column in the text file was number of jobs. The fifth column was number of student seats. The sixth column was number of students. Column 7 was number of workers. And the last column was shopping floor space. Okay, so make sure you have all this specified correctly in the same order. This should be 1, this should be external ID. Give the file address here so it reads. So here, make sure you click import and then OK. Now that we have imported the data, if you click on any of the centroids again, if you go to the land use tab, click on attributes, you should be able to see the numbers imported from the text file to the attributes of each zone. Next, we will create the generation and attraction scenario and the experiment. So if you come under the folder scenario, if you right click on it, new, and then create a new generation and attraction scenario, let's double click on it and change some of its properties. If you go to tab main, you can change the name. Let's make it a generation and attraction scenario 2012. I'm going to choose car, bicycle, and public transport. Trip purposes, work, study, shopping. The time periods is AM peak period. The data comes from the census 2012. I'm going to check this and select all here, so make sure you follow what I've done, and this should be good for now. So if I click OK, I have created the scenario. Now if I right click on the scenario, I can create a new experiment. I double click on the experiment, and again I can change the name to whatever I like, so I'm going to call it GA 2012 and OK. And now right click on it, run the generation and attraction. The window of the results will pop up automatically. And you should be able to see the generation before balancing, attraction before balancing, after it does a balancing like a gravity model. It gives you the number of trip generated and trips attracted for all the transportation modes for different trip purposes, as you can see here. Now let's click on generate vectors so we can generate the results of the generation and attraction. Click OK, and if you go under folder demand data under Centroid configurations, Centroid and subfolder vectors, as you see here, you should be able to see the generation and attraction vectors. So let's have a look at this. So you see we have it for shopping trips, study trips, and work trips. So for example, if I double click on the work trips, I should be able to see the number of generated trips and attracted trips for every single zone that we had in the network. So for example, Zone Mall North has 334 generated trips and 2,500 attracted trips. Now that we're done with the trip attraction and trip generation, we go next to trip distribution and mode choice. So in this exercise, we'll go through the data needed for trip distribution and mode choice modeling, and we'll eventually obtain a preliminary estimate for travel demand before doing the traffic assignment. So for the first step, let's have a look at the data required for trip distribution and mode choice, which is the distribution data set, data in the distribution folder in the Centroid editor, and distribution areas, and the generation attraction vectors, and optionally the travel time scheme matrices. So let's have a look at the demand data. We have the centroids here. Under the centroids, we have the OD matrices. Under this OD matrices, we have the initial or preliminary travel time matrices. The travel time matrix between each origin and destination. So for example, if I double click on the scheme initial scheme matrix car, you should be able to see the travel time between each I and j. Again, this could be travel cost or travel time or any indication of travel time or travel cost, or like a deterrence function. So that's about the initial scheme. Here, again, initial scheme refers to the travel time matrix. Under the function, if you go under the folder distribution model split, you should be able to see different functions specified, which is the distribution and mode choice for shopping non-urban, distribution and mode choice for shopping and urban, distribution and mode choice for study and for work. So for example, if I double click on the distribution and mode split for work, you will see a few lines of code that represents the distribution and mode choice model. Again, you don't have to worry about this scripting at the moment. This is given to you, but eventually, if you really want to work with Aimsun, if you want to become a user of Aimsun, you need to learn how to write some few lines of a script to represent your different mathematical models of distribution models or mode choice, or even sometimes assignments. But for now, this is given. But this is how you actually put the model inside. Also, if I go under the user class folder, I should be able to see different user classes defined. For example, if I go under car, this is the vehicle occupancy, interzonal travel time weight, and etc. etc. Under the main, you see the name of the user class and the attributes, which is the fixed toll weight, junction delay, variable toll. Again, a lot of different attributes can be input when you define a user class. So for now, let's start looking at the user class car work, car study, and car shopping. We're going to change the occupancy parameter in each of them. So for example, for the car work user class, we're going to change the occupancy to 1.3. This is the average number of people using the car going to work. I'm going to change the car study occupancy to 2.7. And I'm going to change the car occupancy of shopping to 2. On average, 2 people use the same car to go to shopping. We are now going to consider that the CBD area has a restricted number of parking spaces, so we'll have this information on the available parking slots for the CBD. So if I go under macroscopic areas, which we saw previously, macroscopic areas folder, if I go, we have CBD, we have distribution area, non-urban, and etc., etc. If I double click on CBD, I should be able to see a list of parking costs, parking search, and parking slots for different modes and different trip purposes. Here, what we're going to do is we're going to specify some parking slots availability. So for bicycles, we're going to do, there are 10,000 bicycle parking slots available. For bicycle shopping, I'm going to do 10,000 as well. So this means actually there is unlimited parking availability for bicycles. For bicycle work, 10,000 as well. For car, we're going to have total of 2,000 parkings available. For shopping and study, we're not going to specify any parking availability. And for work, we're going to do 2,000. The reason is because in the CBD area, I guess in this example, we are only assuming work trips will go to the CBD. And for public transport users, we're also going to specify 10,000 parking slots available for every trip purpose. Okay, so this is about the parking availability. Now we need to create the distribution scenario and experiment. So if I come all the way down on the project panel into scenarios, I right click on the scenario, I create a new scenario, but this time I'm gonna do a distribution scenario. Last time we did a generation and attraction, but this time we're gonna do a distribution scenario. So we created the distribution scenario. Let's go to the distribution scenario properties. Let's change it to distribution scenario 2012, for example. Make sure the generate through traffic is checked. We're not blocking any cells. Time period is AM peak period. We're using the distribution dataset 2012. The distribution functions we're going to use on the departure side, and the parking availability, we're going to choose, instead of none, we're going to choose arrival side. So when they arrive at a destination, that's where the parking availability matters. On the generation and attraction vectors on the right side, make sure all of them are checked. So the distribution model reads the output of the generation and attraction as we estimated last time. Also here on the bottom, where it says matrices per user class, we need to make sure the initial travel time matrices are provided. So for example, for bicycle shopping, we need to choose the initial scheme matrix for bicycle. Leave the true matrix as none. For bicycle study, let's choose the initial matrix bicycle, initial matrix bicycle. For car, initial matrix car. For car study, same thing, initial matrix car, initial matrix car. For public transport, I'm going to do the same. And that's all for this window. And then I click OK. And then I right click on the distribution scenario. I create a new experiment. Let's have a look at the experiment attributes. It has the maximum number of iterations for the gravity or synthetic model that it is using, and that's good enough, so it's all good. Now I'm going to right click on the experiment and run the distribution model. And there it is, the distribution model is completed. What you can see here is the result of the mode choice but by different trip purposes. You can see for work trip, 53% are using car, 8% are using bicycle, 37% are using public transport, for example. And if you want to look at the convergence, you can see that the result is pretty good and achieved in 3 iterations only. That's for work-related trips. If you want to have a look at the study trips, it has been done in 5 iterations, shopping for 4 iterations, and so on and so forth. And this is the graph of the residuals for the convergence. So I click OK. Let's not to forget to generate the OD matrices. If I come back to the experiment that I ran and I double click on it, where I saw the results of the mode choice, I can here click on generate matrices to actually generate the OD matrices for every trip purpose and for every mode. So I click generate matrices, and here you can see under the OD matrices, we previously saw the initial scheme matrices. There are now a couple of new OD matrices for every trip purpose and every mode. So for example, if I click on car, work, trips, I should be able to see an OD matrix showing how many trips will be made between each I and j. Now that we have the origin destination matrices, we need to create some demand profile before doing the assignment. So if you come down to traffic demand folder under demand data, if I right click on it, click on new traffic demand, and let's double click on it. Let's change the name of it to traffic demand car, and let's create a demand profile for car traffic. Set the starting point or starting time at 7 a.m. The duration of the time period, we set it to 3 hours. And here we need to click on add demand item. So what I'm going to do is I'm going to add the car shopping, car study, and car work OD matrices that we generated from the previous step. And we add it to the profile, and that's what you see, a timeline with different demand matrices combined together. So if I come to profile, I should be able to see a static profile from 7 to 10 a.m. and 100%, the trip count is 968 trips. And if I want to, that's for shopping. If I want to do it for all, there are almost 12,000 trip counts. So this is for traffic demand car, and I need to do the same for traffic demand public transport and traffic demand bicycle. So let me do traffic demand public transport, same initial start time as 7 a.m., duration 3 hours, and I'm going to add the public transport demand matrices for shopping, study, and work. That's all. Let's double check the profile. There are a total of 16,000 and almost 500 public transport trips, and that's okay. Let's create another new traffic demand profile. Let's call it traffic demand bicycle, and initial start time same as 7, duration 3 hours, and we add demand item. This time I'm gonna add bicycle shopping, bicycle study, and bicycle work, and I click OK. I go to the profile. I'm gonna check the demand profile. In total, there are almost 4,000 bicycle trips in this exercise. So we're done with creating the demand profile. Now we need to create 2 assignment scenarios and 1 public transport assignment, 1 for car, 1 for bicycle, and 1 for public transport. So under scenario, I right click, I go to new, I create a new static assignment scenario. Let's double click on it. Let's change it to static assignment scenario for car. Let's choose the traffic demand car, and we can also choose the public transportation plan and leave the pass assignments as 0. This should be good for now. Let's click OK. Let's create another scenario, new static assignment scenario. I'm going to this time call it a static assignment scenario for bicycle. For traffic demand, this time I'm going to choose the traffic demand bicycle profile. I'm not going to choose any public transport plan here because Previously, we chose that because of the timetables of the public transport to be included in the background traffic, but for bicycles, it doesn't really matter. So I click OK, and let's create another scenario for this time public transport assignment scenario. And let's double click on it. And this is already public transport assignment scenario. Let's create the traffic demand. Here, this time I'm going to choose the public transport demand. The public transport plan is the schedule that it is giving, that we're giving to the this experiment, this scenario. And it's done. So let's go under the static car assignment scenario. If I click on new experiment, I can choose among different assignment methods. Remember the Frank-Wolf algorithm we talked about, the incremental assignment, the MSA assignment we didn't talk about, and a stochastic assignment which we briefly touched on. Let's keep the Frank-Wolf assignment, and OK. Now let's go to its properties. Let's make sure everything is fine with it. Maximum iteration 50, that's OK. And everything seems to be fine. So let's run the static assignment, run static traffic assignments. It's done. So the mean network occupation is provided, total network distance, total network cost is also given. You can also see the results of the convergence pattern. With 41 iteration of the Frank-Wolf algorithm, it reached convergence. And for these are some of the output of the assignment, the assigned volume, and the cost associated to every link, or we call it section in aimSun, is also provided. So we click OK, that's done. Let's have a look at a static assignment for bicycle. I right click on it, new experiment. For bicycle assignment, let's do a stochastic assignment as we talked about in this in the lecture. So static assignment for bicycle, which is a stochastic one. Let's have a look at its properties to make sure everything is fine with it. Maximum number of passes is 5. That's okay. Let's keep it that way. And let's click OK. And now right click on it, run the traffic assignment for bicycle. There is an error here. We can see that it says no stochastic utility function is defined. That's a very good point. So let's go back to its properties. And actually here we haven't selected the utility function and initial volumes for the stochastic assignments. So for the utility function, let's choose the function bicycles that is already given to this exercise and the initial volumes from the car static assignments. And this should be fine. And then I click OK. Now if I run static assignment, it should work fine. There it is. I have new results for my bicycle assignment. If you go into tab section, and if I change this user class to bicycle, for example, work, I should be able to see the volume related to the bicycle work trips on each link and the associated cost. So that's all good. Let's go on for the public transport assignment scenario. I right click on it, new experiment, and I go to its properties. I'm seeing some of the variables associated to the user class weights for public transport. Transfer penalty function is already provided to this exercise, so let's click on the PT transfer penalty. Multi-routing is allowed, and this should be fine. So let's click OK, and now right click on it and run the public transport assignment. And you can see the results are provided, where you can see the total track length, number of passengers. If you click on it, you can see multiple bus lines that is provided with its number of alignments and boarding. You can also see some histograms related to the number of boarding and alighting and the load, and etc. Now that we're done with the 3 assignments experiments, we can visualize and analyze some of these assignments outputs. For example, if I go back to the static assignment for cars, if I go under the tab pass assignment, I would see all the pass assignments. So if I select any of them, I would see the origin and destination. If I select another one, and if I click on this one, I would be able to see the passes between every origin and destination. So for this specific OD, there are 2 passes that are being used in the assignment. To be able to visualize some of the outcome of the traffic assignment a little bit better, we can go under data analysis. Under view style, I right click on it, I create a new view style, I double click on it, I change this to car volume, for example, and I select section of my objects of type. Section here refers to the links in the network. I'm going to choose the style color. The attribute, I would like to choose the assigned volume. And I'm going to see for all the vehicles. And 1 decimal, let me do 0 decimal, and let me calculate a range for this. 5 classes, k-means, that's totally okay. Let's calculate that, okay. And I have my color range for the assigned volume. So I click OK, and then I need to go to view mode. I create a new view mode. I double click on it. Again, I change the name here to car volume. And I have to add some of the existing styles. I'm going to add this car volume here. Okay, I can add multiple visualizations. So here I'm going to also hidden the centroids and the polygons associated to the centroid, so I can actually select some of the links. And okay, to be able to use this car volume visualization, when you're on the active experiment here, you can actually change your active experiments. I want to make sure I'm on the car. So I want to visualize the car static traffic assignment. What was the name of the experiment for the car? 10305. I think that's what it is now. And I choose the car volume, and there it is. I should be able to see the difference in the car volumes as different colors on my links. So if I click on some of the links here, for example, if I click on this link and double click on it, I should be able to see the assigned volume as 976. If you don't see it as a table, you might be under this tab, which shows you a time series, but again, it's a static assignment, so there's no time dependency. It gives you 1 dot. But if you click on this, you should be able to see the assigned volume.